question 4, we have a curve which has the equation 1 minus 4 upon 2x plus 1 whole square. It intersects the x-axis at A. And the normal to the curve at A intersects the y-axis at B. We have, in the first part, we have to obtain expressions for dy dx and integral of y. So to find the dy dx, it is better to first bring the function x plus 1 whole square in the numerator, which will become minus 2, x plus 1 to the power minus 2. Now differentiating this, 1 will become 0, minus 2 times minus 4 will become a plus 8, x plus 1, and the power will decrease by 1, which will become a minus 3. And as this is a 2x, this will multiply by 2, so the final answer will become 16 upon 2x plus 1 whole cube. For the integral of y, again we'll write it as 4 into 2x plus 1 to the power minus 2. Integrating 1, we get x. Integrating this function, we'll get 2x plus 1. The power will increase by 1 and it will divide by minus 1 and multiplied by the derivative of the function, which will become 2. So the final answer will be x plus 4 upon 2 will become 2. 2 into 2x plus 1 to the power minus 1. Or we can write it as x plus 2 upon 2x plus 1. In part 2, it says find the coordinates of B. Now we know that the normal to the curve at A intersects the y-axis at B. So the equation is y is equals to 1 minus 4 upon 2x plus 1 whole squared. We know that A is the point which is on the x-axis. So at this point, the y coordinate will be 0. So we can substitute 0 over here to get the coordinates of A. So this will become 4 upon 2x plus 1 whole squared is equals to 1. Cross multiplying, we will get 4 is equals to 2x plus 1 whole squared. Taking square root on both the sides, this will become 2 is equals to 2x plus 1. So x is equals to 1 upon 2. So the coordinates of A are 1 upon 2 comma 0. Now first we'll find the gradient at point A and then we'll take the negative reciprocal as B is on the normal at A. So dy dx at point A will be, we know that the dy dx is 16 upon 2x plus 1 whole cube. So this will become 16 upon 2 into half plus 1 whole cube. So 2 and half will make it 1. So 1 plus 1 is 2. So 16 divided by 8 is 2. So the gradient of the tangent at A is 2. The gradient of the normal will be minus 2. Minus 1 upon 2, the negative reciprocal. Now, to find the coordinates of B, first we can form the equation of the normal. We have the point A and the gradient, which is minus half. So the equation will be y minus 0 is equals to minus half into x minus half, which is the x coordinate of A. And now to find the coordinates of B, we know that B lies on the y-axis, which means x equals to 0. So substituting x into this equation, we'll get y is equals to minus half times minus half, which will be plus 1 upon 4. So the coordinates of B will be 0, 1 upon 4. In part 3, we have to find the area of the shaded region. Now we know that the shaded region, basically, we can first find the total area of the curve, under the curve, and then the area of the triangle. So this point is half and this point is 1 upon 4. So the area of the triangle would be half into base, which is 1 upon 2, into height, which is 1 upon 4, which will be equals to 1 upon 16. So the shaded area consists of the triangle and the area under the curve. For the area under the curve, you have already integrated in the first part. So the integrated form was x plus 2 upon 2x plus 1. The limits will be half and 0. So substituting half into the equation, we will get half plus 2 upon 2 into half plus 1 minus substituting 0 into the equation, we'll get 0 plus 2 upon 1. So 1 upon 2 plus 2 upon 2, 1 upon 2 plus 2 upon 2, which is 1, minus 2 upon 1, which is 2. So 3 upon 2 minus 2 is minus half. Now, as we know that the area of the curve was lying beneath the x-axis, we'll get the answer negative. But as area cannot be negative, we know that the area will be positive half. So the area of the triangle, which is 1 upon 16, and the area under the curve, which is 1 upon 2. Simplifying this, we'll get 9 upon 16 as the area, total area of the shaded region.